Imagine a world where time itself feels broken. A world where one side is a scorching inferno, hot enough to melt lead, and the other, a frozen abyss colder than deep space. A world so brutal, it redefines the very meaning of inhospitable. This isn't science fiction. This is Mercury. The smallest, fastest, and arguably, the most bewildering planet in our solar system. Forget what you think you know about our celestial neighborhood. Because what lies beneath Mercury's pockmarked surface, and within its bizarre orbit, is a story far stranger than any myth. For centuries, Mercury has been a celestial enigma. Named after the Roman messenger god, it zips around the sun at a blistering speed, a characteristic that masks its true, terrifying nature. It's a planet of extremes, a cosmic paradox orbiting our life-giving star. But how can a world so close to the sun harbor such freezing temperatures? And what secrets does its peculiar rotation hide? Today, we're not just observing Mercury, we're taking a deep dive, a virtual journey to unlock its most profound mysteries. Prepare to question everything you thought you knew about planetary survival. Our first stop, Mercury's surface. It's a lunar landscape on steroids. Craters upon craters, remnants of a violent past. But the real shock comes when you realize the temperatures swing. On the day side, directly facing the sun, temperatures can soar to a staggering 430 degrees Celsius, 800 degrees Fahrenheit. Hot enough to vaporize zinc and melt lead. Now, imagine stepping into the shade. Within mere meters, the temperature plummets to a bone-chilling minus 180 degrees Celsius, minus 290 degrees Fahrenheit. This is a temperature difference of over 600 degrees Celsius. No other planet in our solar system experiences such a drastic, rapid thermal shock. How could anything possibly endure this brutal cosmic dance? And more importantly, how does a planet so close to the sun manage to have any cold at all? Here's where Mercury gets truly bizarre. Forget our 24-hour days and 365-day years. On Mercury, time plays by its own rules. One complete rotation of Mercury on its axis, what we would call a day, takes about 59 Earth days. But here's the kicker, its orbital period around the sun, its year, is only about 88 Earth days. Think about that. A single solar day on Mercury, the time from one sunrise to the next, lasts an astonishing 176 Earth days. This means one Mercury day is actually 2 Mercury years long. If you were standing on Mercury, the sun would rise, inch across the sky incredibly slowly, set, and then it would be night for another 88 Earth days before the next sunrise. This slow rotation is a critical factor in its extreme temperatures, allowing one side to bake and the other to freeze for extended periods. It's a true testament to the mind-bending physics of our universe. Given the hellish temperatures, you'd think water is impossible on Mercury. Yet data from probes like Messenger revealed a shocking truth. There's water ice at Mercury's poles. How is this possible? The answer lies in the deep, permanently shadowed craters at its poles. Because Mercury's axial tilt is almost zero, the sun's rays never directly hit the floors of these craters. They are eternal ice traps, acting like giant freezers in the middle of a cosmic oven. Scientists estimate there could be billions of tons of water ice, hidden beneath a layer of insulating material. This discovery has profound implications for the search for life, and future human exploration of the inner solar system. Could these frozen reserves be a future fuel stop for interstellar travel? Beneath its cratered surface, Mercury hides another incredible secret, a surprisingly strong magnetic field for its size. For a long time, scientists were baffled. Planets need a molten, convecting core to generate a magnetic field, and Mercury is tiny. How could its core still be active after billions of years? The answer lies in its core's sheer size. Mercury's core is proportionally enormous, making up about 85% of its radius. It's primarily composed of liquid iron, surrounded by a solid inner core. This giant, churning metallic heart creates a global magnetic field that, while weaker than Earth's, is crucial. It acts as a shield, deflecting the sun's lethal solar wind and preventing its atmosphere from being completely stripped away. This robust, active core suggests a violent, fiery birth and a complex internal structure we are only just beginning to understand. It's a tiny planet with a colossal secret. Despite its magnetic shield, Mercury's atmosphere is almost non-existent, a mere exosphere of thinly scattered atoms. It's constantly being replenished and stripped away by the sun's radiation and solar wind. What little atmosphere it has is made up of atoms blasted off its surface by the solar wind, or vaporized by the extreme heat. Elements like hydrogen, helium, sodium, potassium, and oxygen drift fleetingly before being swept away. This constant battle means Mercury can never hold onto a stable, Earth-like atmosphere. It's a planet forever exposed, forever at the mercy of its giant star. This lack of atmospheric pressure also contributes to the Armstrong Limit effect we discussed in our community post, the point where liquids in a human body would boil away instantly without protection. It paints a stark picture of survival. Mercury offers no refuge, no soft landing, no breath of air. Despite our recent discoveries with Messenger and the ongoing BepiColombo mission, a joint European-Japanese venture, Mercury still holds countless secrets. What exactly is the composition of its solid inner core? How did it form with such a disproportionately large iron core? And could the water ice in its craters truly be a resource for future space endeavors? Each new probe, each new piece of data, unravels one mystery only to reveal another. Mercury, the Sun's closest confidant, remains a testament to the endless wonders of our universe. A brutal, beautiful paradox, challenging our perceptions of what a planet can be. From its fiery days and frozen nights, to its time-bending rotation and its hidden reserves of ice, Mercury is a planet that continually astonishes. It teaches us that even in the most extreme conditions, the universe finds ways to surprise us. So next time you look up, remember Mercury, the silent, swift messenger, whispering tales of cosmic paradox from the edge of the sun's embrace. What other secrets do you think Mercury holds? Let us know in the comments below. Don't forget to like, share, and subscribe to The Full Cup for more cosmic journeys.